Thank you. Thank you so much. Today I'd like to go through a brief history of interaction design to talk about specifically how this paradigm of the mediating object and the mediating body kind of evolved in the last 100 years and what its origins are in military research and how that continues to play out in the systems that we use every day. First image, this is Alfred Crimey's illustration of Sperry Gyroscope's gun turret. I love this image because it really shows the human body integrated in a larger electromechanical assembly. And it really treats the body as an engineered system within the rest of that assembly. You see a sort of cutaway of the midsection, the hands there gripping it. And so in a way, there's a sort of philosophical reading of this too, which really treats the body as a sort of machine, and a machine that needs to be codified and understood as a sort of engineered system within a larger assembly. And then I show this image for you guys just to kind of complicate the narrative a bit. While we are sort of exceptional to the degrees that we extend our body into our environments, we're not unique. And this is a little cricket that creates a burrow that amplifies the sound that it would normally produce to better attract a mate or better signal, fellow crickets or whatever crickets do. So just to return to that body in a sort of larger electromechanical assembly, I'm showing these funny control knobs because this image is from NASA's bioastronautics data book. And the culmination of this research that began sort of in the pre-war period in the 30s and 40s continued on through the space program, which was this effort to understand the operations of the body in whole. So both, there's sort of structural proportions and all that kind of stuff, but also how much sweat we produce in certain states of anxiety, and this, really the internal workings of the body, and to codify them so that they might be used just like any other engineered system, like a manual for an engine might be used in the development of the landing craft or the Apollo spacesuit and so on. I'm going to step through a few of these objects that I produce that I call didactic objects. They're there to sort of illustrate certain properties of digital information, and in doing so, they sort of address three different scales. One is the scale of the body, one the scale of the furniture, and the scale of, let's say, an architectural space. They also show the three components of an interactive system. You have the sort of input, you have a processing unit, you have the display, and then you have the body that's sort of integrated in a feedback system in between all those devices. And in stepping through these objects, I hope to also illustrate some properties of the digital. And the first is the discretization of the real. So in this pre-war research, what we found, or what we see, is that there were two paradigms of computing that emerged. One is analog computing, which you may have heard of, but it's sort of less talked about, and then digital computing, which is obviously like the major paradigm that we all use today. And so what you can see is in analog computing, you're actually manipulating the incoming signal and through filters and so on. But in digital computing, you have to discretize that signal. So you have this kind of continuity of whatever that input is, say it's a voice being recorded or whatever, but you have to sample it at a high enough frequency that it starts to approximate the fidelity of real life. But it's always going to be an approximation. So here you have a cube in the middle, and it's represented by a series of slices. So it's not the cube itself, it's a sort of representation of it. And so here's our first object. I call it the Somatic touch and display device. And so here I am manipulating it. It has a soft top that is soft for a reason. It's actually full of prosthetic implants, so things for a rear or breasts or whatever, that a friend of mine has contacts at a plastic surgeon passed along to me. And I use this intentionally because touching it really, it's a material that's made to mimic human flesh, and so touching it is a really estranging kind of experience. And in a way, it talks about that historical moment of looking at the body as a sort of machine, and it inverts that relationship between you as a body and a device as a sort of piece of technology. And so you're pushing on this thing that sort of feels like a body, but you're also interacting with digital information through doing it. It acts just like a touch screen, basically. And the dimensions and kind of angles of the tabletop and so on are all pulled from that bioastronautics data book. And the materials as well is sort of space-age materials, styrofoam, plywood, and so on. So here we take the top off. We have this, this kind of soft, lumpy input device that we can kind of push around, and then there's a display as well. So there are LEDs embedded within it. So the second idea is the malleable reel. So if we think about these digital devices as discretizing the real world around us, what the digital information, or what digital computing offers us that analog computing didn't, was the ability to encode that information, to save it, process it, and then reuse it later. And so an interesting thing about that process of discretization is that it actually mimics the way our bodies process information. So here in the foreground, you see this graph of action potentials, which is how our nervous system basically processes the information in the world. And so you basically have these thresholds, and when a sensory input crosses a threshold, you have this little spike called an action potential. The interesting thing about this is that all of our senses are processed the same. So there's a sort of continuity in terms of the way that information is encoded in our bodies, and then but it's processed differently. And so these fellows in the background, which you might be able to make out, are Manfred Clynes and Alfred Klein and Clynes, which I always like. And they wrote this seminal paper called Space, Drugs, and Cybernetics in 1960, where they coined the term cyborg. Cyborg you may have heard in science fiction, I don't know, Battlestar Galactica, all kinds of stuff. But at the time, they were really thinking about it differently. They were imagining the prospect of a human body in space, this entirely hostile environment, and thinking, okay, well, there's one paradigm, which is to say, like, okay, let's take the entirety of, let's just reproduce an environment in which the human body can survive, and just take that as a little capsule and allow it to survive in space. But they had emerged from 10 years of like the golden age of psychopharmacological research, and had seen the body as this incredibly malleable thing through chemicals. And so they were saying, well, with the prospect of a body in this hostile environment, why don't we just change the body instead? Let's manipulate the body to a degree where it can actually survive in those conditions, which is a pretty provocative idea, and actually influenced NASA's research. So here we have the Apollo-era portable life support system, which was all of the sort of systems required to maintain a body in a hostile environment. And so, we have the things you might imagine. You have oxygen and waste management and a pressurized suit and all those kind of things. But almost just as critically, in the lower right, you have the communication system. And that body floating out in space relies so much on its ability to talk to Houston and hear what it needs to do, where it needs to go, all this kind of stuff. So communications is a sort of and really long distance. This is like the most expensive cell phone that was ever developed. This long distance communication device is really fundamental. So here is the second object. It's something I call the CV Helm, the computer vision helm. And basically what it is a little screen with a webcam behind it, a laptop here and hidden in a bag so you don't see it, and then this little cube that you rotate. So what happens is your vision is being replaced and recreated for you. So you're moving around and it's seeing the world and then reproducing it in front of you. But what this mediating cube does is it actually knows its orientation in space. This little thing in the middle is called an inertial measurement unit. It knows its orientation in space. And above is just a Bluetooth device that allows it to connect wirelessly to the helmet. And what this does is it allows you to manipulate your perceptual experience in real time. So you're rotating this cube, and if you rotate it this way, it might do a certain thing, and if you rotate it another way, it does another thing. Because we're creating a sort of contained environment here where we're controlling what the user sees, we're able to manipulate it through a series of computer vision algorithms. So one might be a sort of scale space algorithm, which just in simple terms, just like blurs the world around you. So, if you kind of blur your eyes a little bit, suddenly you notice that you can only really pull out major structures, but if you open them up again, you can find, fine-grained things. And so it allows us to do a series of experiments looking at the world through these different filters. And this image that you see here is actually, in my thesis presentation, I took this, they assemble a jury of terrifying people to judge you. And so what I did was I removed all their faces, just to spite them. So in the background on the screen, what you can see is this group of people that don't have faces. So It really does illustrate something about the way that we interact in space with people. I'm sure you'll notice this maybe when we're milling about after, that you really spend like 95% of your time or something just looking at faces and trying to read emotions and those kind of, we're inherently social beings. So to go through this experience of seeing a sea of bodies without faces and trying to read information from that experience is really, it's really fascinating. And so ultimately, this is the sort of image of the digitally mediated body at its most explicit. The idea here is in terms of the malleable reel. You may have heard of like virtual reality or augmented reality. Virtual reality, you're blocking off everything, and you're sort of recreating this world that you can inhabit in some ways. Or augmented reality is a sort of overlay of information on the world. And in this case, it's this sort of hybrid where you're seeing the world in a way, but you're able to manipulate it in ways that you can't with sort of a hand axe or other material devices. So the final phrase or saying and the final object has to do with information being medium agnostic, particularly digital information. So at some point, if you think about the abacus, that is a fascinating device because every component of a modern interactive system is in that device, but it's combined in that device. So by moving the beads around on rails, you have a sort of input device, you have a sort of computing system, and then you have the display all happening in real time in front of you. So at that point, the material was information and information was material. But these modern systems are quite different, and they act quite differently. So I created these wall panels as a sort of experiment to explore those ideas. These are called the sensory byte display panels. And so what they do is they each display a byte of information, which is not a whole lot of information. So it's eight things that have a state of 0 and 1. So you could think of it as having a range of 0 to 255 or 256 different states, which isn't really a whole lot of different states to have as a thing, but they help illustrate something. So in the bottom left, you have what I call the value panel, which just has a series of lights around this kind of manipulated landscape. And so as you turn on different lights, it casts shadows in different ways. You just see shadows, basically. And then in this next one, there's a color mixing panel. So you have different colors that blend together depending on what number it's displaying. Above it, 8 fans, so you can kind of feel at different parts of your body, different kind of the representation of different numbers. Right, you have a sound panel. So each one of those sections is actually tuned to a major scale separated over 2.5 octaves. So as a little solenoid on the back taps these little things, you get these sort of different chords that are created. Here are some of the panels and some of the different states that these panels can achieve. So these are basically just binary numbers. So you have like 0, 1, 2, and so forth. But what's interesting is that as these numbers cascade through, you're able to see the same information being displayed through different senses. So you feel in one panel, let's say the number 15 expressed through shadow. In the second panel, the number 15 expressed through color, the number 15 expressed through wind patterns or something. And so what I tried to show is that ultimately, we've become so accustomed to these things as the container of information. These kind of like we've become so reliant on visual information, but it's really only one sense, and there are other ways to display information. And this final panel, which you can see on the bottom here, was a series of spiral patterns that were actually pulled from that bioastronautics data book, which was used for the encoding of visual information for flight panels. And so this one in particular, the forward velocity spiral. So as these things spin, they kind of create these psychedelic kind of effects that kind of give indications of different speeds. So this is like a higher order of abstraction, I suppose, where you're displaying information through a kind of difficult to discern sort of, like series of movements. And all of these devices were totally handmade, and they rely on this small device in the middle. It's called a shift register, which basically just allows one number to be sent along and without any understanding of what's going on around it. So these panels can be totally reconfigurable. You could have 10,000 of them. You could have 2 of them, and they wouldn't know and wouldn't care. So that was kind of built into the system intentionally. So what are the implications of this work? Why talk about things in this weird way? Why even investigate these sort of alternate ways of interacting with information? And so ultimately, I mean, like I was saying, the objects in our environment influence our agency as human beings. I mean, so to be a designer is an inherently political act, it's an ethical act, it's a philosophical act. We're basically trying to structure the way that we operate as human beings in the world. And so here's just from a couple days ago, me in the wilderness with some of my fellow Sitka fellows, taking a picture, reclining on this piece of old growth in the middle of the forest, and then shocked to see that I have 2 bars of 3G here in the middle of nowhere. And so I text my girlfriend, I say, hey, check it out, I'm in the wilderness. And so I think that this, and she's on the East Coast, and so she, in a way, gets to experience my experience in the wilderness in Alaska while sitting in her sweltering apartment in Boston. And I think that this is really interesting, this conflation of time and space through digital communications, and what the implications are on even the notion of wilderness. I mean, what are the boundaries of wilderness if we can take a cell phone out there, take a picture of ourselves, and transmit it across the country? Is that really wilderness anymore? What are the sort of limits of I don't know, a city or urbanization? I think they're just fundamentally interesting questions to me. So this diagram that's overlaid on top is Hagerstrand's space-time geography model, which he devised this ingenious way of representing people moving in space and time simultaneously. So on the bottom you have a sort of 2-dimensional grid, which is people moving around, and then the vertical axis is time. So you can see people moving and coming together and so on. And so he has a meeting, which is people coming together and sharing a space. But then interestingly, he has this moment of a telephone call. In this telephone call, they're able to not so much inhabit the same space, but maybe share some understanding of space. And so I think the big promise of digital communication technologies is that they expand our human agency in ways that we couldn't have imagined previously possible. So thank you so much.